Hello everyone, today we're going to be talking about exponent rules. So before we get into our multiplying, dividing an exponent to an exponent, let's talk about what an exponent actually is. So an exponent is that small little number we see above the base, and I want you all to remember these terms, base and exponent. And most of you probably already know this, right? But let's take 5 to the 3, right? 5 to the power of 3, or 5 to the exponent of 3. Right, that's the same as 5 times 5 times 5, which is just 125. These are the rules when we're multiplying and dividing. So the first rule, the most important rule, is the bases must be the same. If the bases are not the same, we cannot multiply and divide or simplify any values because the bases just have to be the same for us to combine them. So when we multiply values, we add their exponents. And when we divide values, we're subtracting those exponents. To start off with here, we'll just do a couple of examples with an integer base. So let's do 2 to the power of 3 times 2 to the power of 2. So remember, when we multiply values with the same base, and these do have the same base, right? They're both, the base in both of these values is 2. We add the exponents. So this is the same as 2 to the power of 3 plus 2, which is equal to 2 to the power of 5. And 2 to the power of 5, just remember from previously, that is 2 times 2 times 2 times 2, and then a fifth 2 there, which is equal to 32. Remember, 2 to the 5 means we are multiplying 2 5 times. So another way to think about this, just so I can prove it to you all here, right? 2 to the power of 3, this value is 2 times 2 times 2, which is 8, and then times 2 to the power of 2, which is just 2 times 2, which is 4. 8 times 4 is 32. So you see here, using our rule, we get the same value. Now, when we divide here, let's just use the same values, 2 to the 3 divided by 2 to the 2. This is equal to 2 to the 3 minus 2, which is equal to 2 to the 1. And whenever we have something to the power of 1, that is just equal to 2. Or sorry, that is just equal to the value that we're putting it to the power of 1. Usually we just write 2, or like whatever the value is there. So let's say we have 16, right? 16 is actually equal to 16 to the power of 1. We just don't write that 1 there. And again, I can prove this right here to you. So 2 to the power of 3 we said was 8, and 2 to the power of 2 is 4. 8 divided by 4 is equal to 2. So again, we're getting those same answers there. Quite often, you'll be given problems where you'll be having to evaluate values with variables as our base. So let's do some problems with variables for our base. So we'll start just with, let's say, x to the power of 5 times x to the power of 3. Now these do have the same base, right? We don't know what x is, but since we're saying both those bases are x, both of those bases are the same number. So therefore, we can multiply them, we can combine them. So when we do this, right, this is going to be equal to x to the 5 plus 3, which is equal to x to the 8. Let's do a division problem here as well, just using the same values. We'll take x to the 5, we'll divide it by x to the 3. And it's important to remember that we are subtracting the bottom exponent from the top exponent. So the exponent in the denominator, we're subtracting that from the exponent in the numerator. So this is equal to x to the power of 5 minus 3, which is equal to x to the power of 2. And also, for future reference in this video, feel free to pause and try these problems on your own before I go through them and solve them. This next example here is just to reiterate that rule we've been talking about before, where we can, if the two values have different bases, they can't be multiplied or divided. So let's say we have a problem that is x to the 3 times y squared, so y to the 2, and then divided by, this whole thing is divided by x squared. Now these x's here, I can do something with the x's, but the y squared, I can't divide that by x squared because they have different bases. So what I'm going to do is I'm going to split this apart into two problems. I'm going to say this is equal, and it is equal to x to the 3 divided by x squared times y squared. And these two are the same. So now that I've simplified it into this, I can simplify even more as x to the 3 minus 2 times y squared, which is equal to x to the 1 times y squared, right? And that overall is just equal to xy squared. So you see, we can simplify it with the x's, but we couldn't simplify the y anymore. So let's say we have y squared over x to the 2. So y squared over x squared. This is as simple as it gets. There is no simplifying from here. There is nothing you can do to simplify it more unless, let's say, you wanted to move the x squared into the numerator, but we will talk about how to do that later. A special case that some of you may have encountered is when we have an exponent of 0. So what do we do when we have an exponent of 0? And this is one of the most important rules of algebra as a whole. Anything to the power of 0 is equal to 1. So 3 to the power of 0 equal 1. Let's say we have 1,000 to the power of 0. That's also equal to 1. Negative 1 to the power of 0. That's 1. This goes on and on and on. Now, I'll show you why this is true. So let's say we have 3 squared divided by 3 squared. Let's use our division rule here, right? So this is equal to 3 to the 2 minus 2, right? Which is 3 to the 0. So what I'm telling you is that 3 to the 0 is equal to 1. Now, let's think about this in a different way. So 3 squared is 9, divided by 3 squared, which is 9. That's equal to 1. So you can see here, it's kind of visualized why anything to the power of 0 is 1. But it's really, really, really important to remember this. Anything to the power of 0 is equal to 1. The next rule that we're going to talk about here is when we raise an exponent to a value that already has an exponent. So let me show you all what this will look like. So we can have x to the power of 3, and put that in parentheses, to the power of 2. So when we have this, we are multiplying them together. So this is equal to x to the 3 times 2, which is equal to x to the 6. And again, I'll show you why here. So this right here is the same as x to the 3, right, squared. So x to the 3 times x to the 3. And then we can use our addition rule here, right? This is x to the 3 plus 3, which is equal to x to the 6. Now, the way above is much faster and much more efficient, especially for larger problems. So we'll usually use that. Now, this actually is also true for negative exponents, and this will actually lead us into our next subject. But let's say we have x to the power of 4 to the negative 2. That's equal to x to the power of negative 8. And we'll talk about that now. So we have negative exponents. What do we do? What can we do? So let's say we have x to the power of negative 3. This is actually going to be equal to 1 over x to the 3. Now, this is actually, there's a bunch of different ways I can show this. I'll show you one way here. So 1, right? Remember I said anything to the power of 0 is equal to 1. So I'm going to say, okay, we have x to the 0, right? Because this right here, x to the 0 is equal to 1. X to the 0 divided by x to the 3. So 1 divided by x to the 3 is actually equal to this, right? And let's use our subtraction rule here. This is x to the 0 minus 3, which is equal to x to the negative 3. Now this also works for the opposite direction too. So let's say we have 1 over y to the negative 5. This is equal to y to the 5. And I'll show you why here. So remember 1, anything to the power of 0 is equal to 1. So let's say we have a y to the 0 divided by y to the negative 5. This is equal to y to the 0 minus negative 5, right? So we're subtracting a negative here, right? So we're actually adding. So this is y to the 0 plus 5, which is equal to y to the positive 5, just like we saw up here. Now, this is the last rule that we'll go over, but what if we have different bases to the same exponent? So let's say we have, inside parentheses, we have x to the power of 3 times y to the power of 4. And this is all to the power of 4. Now, we can actually treat this as just a distribution problem. We can distribute this 4 to the y and the x separately. So we're going to be multiplying here. So this is equal to x to the 3 times 4. And then that is multiplied by y to the power of 4 times 4. So the final solution here will be x to the 12 times y to the 16. The last thing that we're going to do here is we're going to combine what we have learned to solve a large problem. So the problem that we're going to solve is x to the 4 times y to the negative 2, and then all of that to the power of 2, divided by x to the power of 6 times y to the power of negative 3. So the first thing I'm going to do here is I'm going to simplify this. I'm going to distribute that 2. So this is going to be equal to x to the 4 times 2, right? So x to the 8, and then times y to the negative 2 times 2, so y to the negative 4. And this is all going to be divided by x to the 6 times y to the negative 3. Now it's important to remember, like we did before, we can break this problem up, right? This is the same as x to the 8 divided by x to the 6 times y to the negative 4 divided by y to the negative 3. So let's just take x to the 8 divided by x to the 6. This is equal to x to the 8 minus 6, which is equal to x squared. And then for the y's, we have y to the negative 4 divided by y to the negative 3. This is equal to y to the negative 4 minus, it's important to remember that we are subtracting a negative here, so minus negative 3. So this is equal to y to the negative 4 plus 3, which is equal to y to the negative 1. So now we have x squared times y to the negative 1. But most of the time your teachers are going to want this in all positive exponents. It's one of the most common things that your teachers will want is teachers will want all of your answers in with just positive exponents, no negative exponents in your final answer. So remember that y to the negative 1 is equal to 1 over y to the 1. So this is equal to x squared over y to the 1, which is equal just to x squared over y. And this would be our final answer from that whole jumbled mess on the top there. Thank you so much everyone for watching, and let me know if you have any questions. You can just ask me in the comments and I'll try my best to get back to you as quickly as possible. And as always, my email and my link for one-on-one tutoring is in the description of this video.